Felipe. Welcome. I'm very glad to have you today to do this live Ask Me Anything session about sandboxing.
Thank you very much for the opportunity. It's a pleasure to be here.
Yeah, so now that we started, can you introduce yourself? So, who are you? What is Unikraft? By the way, that's the only moment where you can talk about Unikraft, and the rest of the discussion we'll talk about more generic information, if that works for you.
Sounds good. Hi, everybody. I'm Felipe, CEO of Unikraft. I'm originally from Argentina. I lived in the US, in the UK, in Germany, so I'm a little bit of a nowhere person. I come from a research and open source background, first working in technology called unikernels, which are specialized virtual machines. Think of instead of grabbing a Ubuntu image and putting an Nginx web server on it, building a custom operating system that only runs Nginx. And so then the image is just like 1 meg in size and boots right away. That's sort of where we got started. And then we tried to apply that to the cloud. And we were looking at the cloud and saying, okay, what are the common problems of the cloud in terms of scale and efficiency? You probably know about cold starts and warm pools and exploding billing. So we try to think, okay, if we had to design the cloud with scale and efficiency in mind as a first-class citizen, what would that look like? And unikernels were one part of it, but that got us into a big rabbit hole of redesigning controllers and a lot of the key components of a cloud architecture from scratch. The end result is what we call Unikraft Cloud, which is a platform that you install on an x86 or ARM server, and then it allows you to run millions of instances or hundreds of thousands of instances on a single box. Everything starts in 10 milliseconds and so forth. So I'll stop any sort of selling of my product right at this point, and let's just get more generic.
Yeah, and so today we wanted to talk about sandboxing. And the first question I have is especially for people who are listening that are not familiar with sandboxing. So can you explain what sandboxing is in the context of cloud computing?
Yeah, so sandboxing falls under the umbrella of what's called usually isolation, right? So when you go to the cloud, the assumption is you're sharing hardware. And usually you're sharing hardware with you don't know who, right? And so the provider of that cloud platform has to make sure that you can safely run whatever workload you want next to even a potential competitor on the same box, and that the competitor, will never be able to steal your secrets, harm what you're running, right? And sandboxing is a generic term to say you can run whatever you want, and you will never be able to have negative effects on whatever is running on that same server besides you, right?
And so I'm not like a big expert on the topic, and for people like me who are not super familiar with the concept, so for me, when I hear about sandboxing, I think about virtual machines, containers, micro-VMs. So I'm not sure about the difference between those different terms. Can you explain a little bit what's the difference?
Yes, of course, and it can be confusing. And if people are confused about the differences, that's totally normal. They're all sandboxing mechanisms, let's say. So at the lowest level, modern CPUs, and for many years now, they have what they call virtualization extensions, which are basically additional parts in the CPU that allow you to strongly isolate different workloads, right? And the technology that makes use of that is something called a hypervisor. You may have heard of KVM, you may have heard of Hyper-V in the Windows domain, maybe Zen. And those are very, very, let's say, thin operating systems that make sure that different virtual machines that run on top can share the hardware safely, leveraging these CPU extensions, right? So that gives you generally speaking, in isolation, the lower you are in the stack, the closer you are to the hardware, the stronger the isolation is. So that's like the bottom layer. Hypervisor runs on the bare metal, and then the virtual machines come on top, right? The containers are one layer higher, right? The containers, you assume you already have an operating system, so you could have the hypervisor and then the operating system on top, which can be Linux, it can be Windows, FreeBSD. And then on top of that, you will be sharing the same operating system with any container running on top of that, right? The problem by then is that you are sharing the entire operating system kernel with your potential competitor. So if there's any vulnerabilities in that now much bigger code base of the entire kernel, then potentially a malicious person might be able to break out of their container and go into yours, right? So the name of the game, generally speaking, is you want to be at the lowest level of the stack. You want the code that's running under you to be as minimalistic as possible, so it's as hardened as possible. So virtual machines are generally the golden standard for running sandboxing on the web, on the cloud. And what typically happens when you deploy a container on the cloud is that it gets deployed inside a virtual machine. Sometimes explicitly, sometimes implicitly, but there's very few places that will happily run a container sort of on bare metal. There'll be a virtual machine in the middle to make sure it's isolated. And then to finalize the answer, you asked about micro-VMs. Micro-VMs by definition is any virtual machine that is started with something called Firecracker. Firecracker is a project from AWS. It's what they use for Lambda and some of their other services. It's open source, so anybody can grab it and install it. And Firecracker, it's what's called a virtual machine monitor. It's a fancy term to say a user process that says, please start this VM, stop this VM. And the particular thing about Firecracker is it can do so fast, and it consumes little memory itself for each virtual machine it launches. So by the definition of the AWS people who came up with Firecracker, any virtual machine that you start with Firecracker is called a micro-VM. Now, the virtual machine itself maybe is running Ubuntu and it's consuming 3 gigs. So now you have a 3 gig micro-VM. That's what things get confusing. But by definition, start Firecracker, start a VM, that's a micro-VM.
Okay, that's much clearer now. You mentioned security, so now you got me confused. Is sandboxing more for security or performance?
So generally speaking, at a high level, security and performance are at odds. It's almost like if you get more of one, you have to compromise on the other, right? This is also why you have CPU extensions, as I was speaking about earlier, because those were added so that you can have higher isolation security without performance sacrifices, right? But generally speaking, what's really tricky is how do you make it so that you do have virtual machines which are a must in a multi-tenant environment, but don't suffer from performance problems? Because now you've added another layer. You have the virtual machine, you have the hypervisor in the middle, and you have the hardware at the bottom, right? You're not running bare metal. You're not running as a virtual machine directly on the hardware. So you do take some performance hits. And a lot of the tricky engineering work that we and others do is how do you provide that virtual machine strong level hardware isolation that you have to have while not incurring performance problems. So we can get into this, but if you ever heard of cold starts or things on the cloud that take seconds to start, it's not only this part, because there's also proxies and other components that are slow, but this is one part of the equation. So generally speaking, security very important, performance very important, and if you are not careful about how you do your engineering, they're going to be at odds with each other.
You mentioned cold start. So can you explain a bit more what is cold start and the concept of serverless in relation to cold start?
Yeah, so the idea behind serverless is you just deploy an application and it just automatically runs and it's always available. The response time is super quick, and it'll sort of infinitely scale, right? That's sort of the promise. You can deploy anything you want, any environment, no constraints. The reality of serverless is you deploy it. Most of the time it starts quickly, but sometimes you get a spike of how long it takes for the response to arrive. That's called a cold start. A cold start means that, like the first time you deploy something, AWS, if you're taking Lambda, but there's equivalents in the other hyperscalers, it'll have to set that virtual machine up. In the case of Lambda, it's actually micro-VM. They're using Firecracker. that first initial start takes a certain amount of time. And of course, there's proxies and other things in the middle that need to get set up. That's the cold start. So maybe it'll take hundreds of milliseconds to get that started. And that's usually noticeable by users. That's not great, right? The next request, the second request, the thing is already running. So there's that setup time is not there, and it'll reply much quicker, right? So, and then subsequent requests, they'll get replied very, very quickly. The problem is when those requests die down, the idea behind serverless is, hey, it's idle, let's put it to sleep, right? And then let's wake it up just in time. The problem is when it goes to sleep, if you're not careful about how you do it, you'll incur that cold start again, and then it's noticeable. So there's a lot, that's a fundamental problem, right? And the way it gets worked around it, my opinion is hyperscalers should fix this, but they don't. And so the users have to do workarounds, and there's very bad workarounds. Like some people have to resort to pinging the instance from time to time so it never goes to sleep, right? Other people say, okay, I cannot use Lambda. You go to ECS, build a container, and leave it running forever. So there's never cold starts. It always replies all the time, but then you're paying 24/7 for something that runs forever. And that's essentially what's called warm pooling. So you get into workarounds and hacks that have problems as well.
Yeah, and because there is one concept that you just mentioned, which is the cost concept, and I'm assuming that cold start is basically the side effect of keeping your cost down. And if you don't want to have it, well, you just pay for resources that you're not using, which only a handful of actors can actually do. But at the same time, who actually is burdened by the cold start? So, because you said the users notice, but how many companies, how many applications right now have so much scale and so much adoption that they require this cold start problem to be removed?
Yeah, in cold start is not for sure. There's many companies that suffer from cold starts. I even had people say, "Hey, we just resorted to renting bare metal servers and running them 24/7 because then we don't have cold starts and the price is not that bad." Also, serverless services like Lambda, they start really cheap and at some point they get really expensive. So there's many companies that have grown with Lambda and they've gotten to a point where they have to switch off. But even before you hit scale, there's other limitations in things like serverless. It's not just cold starts. There's also maximum number of invocations, how long your function can run for before it gets killed. And frankly speaking, if I'm a cloud engineer and I want to deploy my app, I don't want to be thinking about all these limitations. Serverless was supposed to be like some magic server concept where I just pay as you go, but it just operates like a server. It can run anything. It can run it as long as I actually need it, and I just get billed for use. That's not the reality of how it works, right?
So then, what's the solution? So, what are the because you mentioned workarounds. So, what are the right solution? What should hyperscalers do? What should CTOs do to solve that once for all?
Yeah. So what we would like to do is the ability for a cold workload to wake up in, let's say, 10 milliseconds, right? Something where it's negligible and the end user would never notice. If you were able to provide that, then nothing should be running idle. You should be able to scale everything down to zero and then wake it up just in time. If that's the case, then you could imagine I have a 1 million user base, but only 100 people are active. Then I can dimension my system for 100 people, not 1 million. Then I get much better unit economics. And so you get this flywheel going of scale and efficiency. That's the world we should live in. But in order to do that, you have to resolve some of the under the hood technical components. Like, when in a cloud platform, when you get a request, it's going to go through a proxy, and you better have a proxy that's going to be reactive in under milliseconds and be able to scale to millions of connections, right? Because what I'm going to be describing is a chain, and what really matters to the end user is how fast the entire chain is. And if any of these components is taking hundreds of milliseconds or a second or whatever, the end user is going to see that time, right? So proxy, then there's going to be a controller. There's a piece of software that's going to say, oh, I see this connection. Do I know about it? Do I need to start a new virtual machine? Do I need to start a container? What's the service, etc.? That also needs to be scalable. Can I run hundreds of thousands of these things on a single server? Can I start things in milliseconds? And then that'll talk to a virtual machine monitor like Firecracker. Firecracker was built for scale and speed, so you could leverage that. And then even if you get to the end of that game, some of the applications themselves can take, let's say, a second to start, right? And then your entire millisecond chain becomes a 1 second chain because the application took 1 second to initialize. There's tricks you can play there too. There's something called snapshotting in the virtualization world. You may have heard the term, but snapshotting is essentially you can take a picture of the running virtual machine at whatever state it's in. So one of the tricks you can do with that is you let the applications fully start. Maybe it takes a second, 2 seconds. Maybe it's a Python application. You need the runtime to start. And after 2 seconds, it's ready to operate. So what you would do is take a snapshot at that state and then put it to sleep and then offer it to your clients. Then your clients send requests and it'll wake up from that state, pre-initialized state, and then it can respond right away. So that's another trick that you can do to make sure that the entire end-to-end chain is millisecond responsive.
And can you share maybe some examples of use cases or industries where the performance that you're talking about is really that important? For example, I'm really curious to understand what's happening now in the AI infrastructure world with AI application provider or GPT wrappers offering a user interface on top of inference. What kind of problems that they're having that you're seeing in the market, and maybe after that I have a question about more industrial manufacturing setups.
Right. So the AI wave, or I guess rather AI tsunami, and by the way, as big as we think it is now, I think it's only the beginning. It's putting a lot of pressure on all of these problems that I'm describing. If we think scale is bad, the infra handling scale is bad, it's going to get worse. Because basically what I've been describing is the way we solve these problems is by throwing money at the problem. We just start more servers, we just leave them running forever. And AI companies on the back end are doing a lot of this. They're burning through a lot of infra costs. So as to use cases, basically you can imagine there's billions of agents, and those agents need to be running in a sandboxed environment like a virtual machine, right? And they only need to, the scale is massive. They basically need to ideally pop up immediately, run for a second or two, and then go back down, right? So this is gonna be a problem for current infra. And the way you would handle that is, hey, whatever, I'll just leave 50 servers running forever, and when I need more, I'll add more servers. And that's how you handle it, which gets really expensive. There's a lot of AI companies that have a lot of revenue, but a lot of burn behind it, right? So that's one part. The other part is these agents are generating code, Python, JavaScript, whatever, and that code needs to run. Hopefully sandboxed, because you can't trust that code. You have no idea what it is or what it's doing, right? So same thing, lots of different code. So big scale, needs to come up rapidly. It's only going to be used from time to time. It needs to be secure, right? And the third part, there's 4 components. And the third one is headless browsers. So imagine Chrome, but running without a UI. This is what agents use all the time to interact with the web. And so there's a lot of companies and a lot of agents that need to use this. So they need millions of these browsers, like huge fleets of them. But a headless browser usually is like an 8 gig beast that takes seconds and seconds to start, to run just seconds. So if you can start them right away, you get much better value for money. So that's another problem. And then eventually also inference itself. How do you make it so that you can run an inference workload and have it pop up immediately and reply? So all of those things would benefit from the sort of fixes that I'm describing. But yeah, the AI world is going to exacerbate this problem.
So you got me really interested by the code part, because that's something that we don't really think about. But even for simple math question or asking LLM to generate a chart, there is code involved. And that's a
Yes.
very, very basic use case. I'm not even talking about code generation agents that will be generating more and more code. Do you have like maybe an observation or a prediction about what's going to happen in the coming years with code generation and code generation agents running in big AI infrastructure, especially in the context of enterprises running those agents and not necessarily renting inference at OpenAI or another provider?
Yeah. So I mean, if the AI chain basically that you have training at the very beginning, and that's massive GPU farms from the really big players, right? And when the models are trained, then you have the inference part of actually using them. That today is still going to mostly the big players, right? But as you're saying, enterprise doesn't want to rely on them and probably wants to feed sensitive data that they won't be happy sharing with Anthropic and company, and they're mostly on-prem sort of outfits. So yes, increasingly you're gonna see people running inference much more locally. So the dynamics that I'm sort of describing will become more and more important as we go forward. And then from there, once the engines are running, so increasingly what you see is you need the need for agent sandboxing, right? Because it's no longer the case that you just want to run a query. Sometimes the agents need to interact with files and generate files and spin up a headless browser to fetch some information from the web and come back and from there generate code. So now you need a fairly potent but sandboxed environment that hopefully starts quickly, right? For the same reason, right? If the sandboxing environment gets more complicated because you need all of these components, and now it takes 10 seconds to start, but the agent needs to then run for 2-3 seconds, then your overhead is horrible too, right?
And what are the solutions that you're envisioning for this problem? Because the way you describe it, it absolutely doesn't make sense to wait for 10 seconds for an agent to run for 1 or 2 seconds. So what are we doing wrong right now, and what can we change?
I mean, we're not doing anything wrong because obviously we don't do that. What we do is we leave warm pools of stuff running forever so that it doesn't take
Yeah,
10
but
seconds.
but it costs a lot of money.
It costs a lot of money. Yeah, absolutely. So it is expensive to run this as infra, but so right now there's so much revenue coming that you can then distribute it back to, if I'm an AI company of this sort today, I get a lot of revenue coming in, and then I'm a proxy for it towards Anthropic and Co. and hyperscalers and Co. Right, for inference and for infra. Right, that's the current situation. It's not great. So a much better solution is if you had technology that could make it so that that end-to-end millisecond chain that I was describing actually existed, right? So a fast controller, a fast proxy, a fast VMM, snapshotting, all of this in place, so that environments could be spun out right away. And then what that allows you to do, if you could do it, is you could bin pack things. So at any one point in time, yeah, okay, maybe you have a service that consists of let's say 1 million users, each with their own agent, or 1 million agents, right? Normally, traditionally, you would think, how many servers do I need to provision for this, or how many containers on ECS, or etc., right? But if you know they're not going to be active all the time, let's say only 1% are active at any one point in time, now you're looking not at a million, now you're looking at 10,000, right? So 10,000, then you have maybe 50 vCPUs on a server. Now you're like, oh, I could, maybe with a rack or 2 racks of servers, I can cater to my 1 million user base. And that's a much more sane place to be, and they will scale better because each server gives you a lot more headroom than today, right?
Another industry I wanted to explore with you is manufacturing. So
Mhm.
I meet a lot of manufacturing company CIOs, and most of them actually are very big on Kubernetes.
Mhm.
So can you explain why Kubernetes has seen such a rapid adoption in manufacturing industrial environments, and what are like the specifics of this industry that requires sandboxing, and which one is the best?
Yeah. So Kubernetes more generally, what it is great at is abstracting, and it's an API basically. In the API, you can express what you want from what could be a very complex cloud platform in very simple terms. Not kind of saying I need a server, I need a proxy, I need this, but rather in a very high level language is here's my service, here's how I want it to scale, here's what I want it to happen when a piece of hardware breaks, right? And so Kubernetes is really good at abstracting the complexity of the underlying platform in very simple terms, and making sure that that interface looks the same whether the backend is in EKS or in some other platform providers, right? So it makes sense that Kubernetes is very widely deployed. The problem with Kubernetes is it's big, it's slow, definitely not millisecond timescale. So that would be like a whole other discussion. How do you have a reactive Kubernetes? In industrial applications, I mean, part of that is probably, but I wouldn't claim to be an expert in that part, but a lot of it is to do with industrial applications. Now you're talking the enterprise world. The enterprise world has teams to be trained on Kubernetes and things like that. And so Kubernetes is like the golden standard for, runtime platform management, right? As to why you need isolation, same thing. It is still a multi-tenant environment, right? I'm an enterprise. I have many clients. If I want to converge them onto common hardware, I'm going to be using hopefully virtual machines, containers inside them, and then Kubernetes seems like the logical choice to be managing all of that.
Yeah, that makes sense. I want to go back to unikernels because that's the bet that you're doing, and of course, this is not a pitch session, but I'm really interested to understand why did you decide to bet on unikernels, and why do you think that they have a bright future in the sandboxing world?
Yeah, so I think the whole trip started like, gosh, 10 years ago, if I'm frank. I don't recommend anybody to start something and work on it for 10 years before it gets to fruition. If you can do it in a few months or a year, that's recommended. But basically, back then, we were trying to, it was the moment of the container wave. I don't know if you remember, Docker was coming out and Docker was a silver bullet. Isolation is amazing, security is amazing, it starts right away, it's the thing to use for any sort of deployment. I think we've gotten over that wave over time, but back then we were in the research world and we were trying to sort of sound the alarm of saying containers are not safe, they're not that fast, and also dispel the myth that virtual machines are intrinsically and fundamentally big and slow. A virtual machine, pun intended, is essentially a container. It's just a shell, and inside it, you're going to put an operating system and a distribution and applications. So that shell is as big, as heavy, or as lightweight as what you put in it. By default, everybody was, still is to some extent, putting big distros on it. So it seemed like a bit silly to, if I want to run an Nginx web server, to put a 1 gig, whatever, Debian distribution on it. People do this less and less now, but back then it was like that. So the idea was, what I care about is I need a server to run things on, and I need my web server to run on top of it. And anything between those two layers is overhead and CRUD. So it should be as small as possible, right? So what is the tiniest possible virtual machine shell I could put such that the web server actually runs? And at first, we were targeting a single application and building things by hand, a little tiny operating system inside a virtual machine that can only run that web server. And you get amazing performance, of course, because now the image is just a few megs, which is mostly however much the application needs. The I/O is really fast. It starts maybe in 1 or 2 milliseconds, right? And then the idea was, how do you extrapolate that so that now I'm manually building this, coding it, and it takes me a month or two, and it's only one application. How do I build sort of like a build kit that I can just say, this application now, please? You hit a command, and then out comes a specialized virtual machine, a unikernel. So that was the bet. And then we ended up extrapolating those same design principles to controllers and proxies and all the other bits and pieces that make a cloud platform.
So what's the future then for unikernel? So in a more and more agent-first world that you described earlier, especially with millions of agents that will be switched on and off for a few seconds using headless web routers, generating code. So where does unikernels fit into all that?
Yeah, I should say I'm not claiming that everything in the world will run on unikernels, but in the AI space, especially the generated code, Python, JavaScript, Go, whatever it is, these snippets of code, that's where the massive scale comes from. I think it's a very good fit for unikernels because you shouldn't use a big VM with tons of stuff on it just to run a snippet of code, right? A unikernel seems like a natural, perfect fit for that. For more complex things, like if you have like a very complex agent that needs files and 10 programs to do its work, you can always take a tiny Linux virtual machine and optimize one and do it in that virtual machine. And the two can work together, of course. The things that fit for unikernels, use it for unikernels. The other things use Linux VMs. But the idea is, hopefully, if all the other platform components are optimized, even when you have some things be unikernels, some things be optimized Linux VMs, hopefully everything can work in millisecond scales and get the properties we've been talking about this whole time.
Now we are approaching to the end of this discussion, and I still have a few questions, more future-oriented question and observations that I want to get from you. The first one is we cannot talk about sandboxing and virtual machines without talking about VMware. And if there is one thing that CTOs are telling me is that they are telling me, hey, with the VMware acquisition, everything is changing. So for those who are not familiar with why the VMware acquisition is like such a massive change in the industry, can you maybe explain what happened and what's the impact for the sandboxing world?
Yeah, sure. So most of the conversation has been centered around hosted platforms. So the hardware belongs to a hyperscaler or equivalent, and you just go and deploy your thing and they take care of everything. But there's a humongous world called on-prem, where people own their own hardware, run a cloud platform themselves, and the hyperscalers are not involved in that at all. So the world of enterprise is run by a ton of things. Of course, enterprises also use hyperscaler, but they often have uses for having their own data centers on-prem. And so in that space, the golden standard for what you would use as software to run on that hardware was VMware. And VMware was software that allowed you to turn a bare metal server into something that you could build a cloud platform on, where you could run isolated virtual machines on top, right? And so the world was really good. And then they got acquired, and Broadcom basically, Broadcom is a company that has few massive customers, right? And this is my extrapolation. Probably they're applying that same principle to the VMware acquisition. VMware had obviously big customers, but also a longer tail of somewhat smaller customers. And what Broadcom is doing is sort of cutting that tail off and saying, if you're not that big, you're too expensive for us to cater to you. We're gonna sort of increase the prices. The big players will pay them, and the small players won't pay them. And so it leaves a huge gap for all of these people who are now orphaned, and they're like, why are the prices so large? This is a mess, right? And so there's a big, massive shift to quickly find equivalent providers of on-prem virtualization technology.
And so here's my next question about on-prem. So there has been a lot of chatter in the tech community about moving out of the cloud. Um, Especially some companies started making a big splash about it, saying, "Hey, cloud computing costs so much, so I went back to bare metal, and because I know how to do it." And the reason why people stay on the cloud today is not because it's more scalable or less expensive. It's really because they're uh, not skilled at managing on-prem and or have your own cloud. So what's your analysis of the current situation? And are we going to see more and more companies getting out of the cloud? Or with the whole AI wave that happened since then, are we going to see still a lot of enterprises that are not technology companies still like going to the cloud because this is still ongoing?
Yeah, it's a super interesting question. I think that the term that gets thrown around is repatriation, um, where basically you're running on the cloud and then you're like, should I consider buying or renting, which is really easy these days to rent bare metal servers and then doing it on my own. I think there's lots of, it's a spectrum, and I think there's lots of interesting data points along that spectrum. Obviously, when you reach a certain, so if you're enterprise, there's workloads that absolutely you have to run, as we were describing, for on-prem, right? Because the data cannot go to a hyperscaler and for many other reasons. And at a certain scale, it makes a whole lot of sense to be running your own infra. And in addition, at a certain scale, you probably have an SRE team that can handle that for you, right? So it kind of makes sense. In general, it makes sense for everybody, but not everybody has those sort of teams. And so a lot of the reasons why, especially earlier companies, go to the hyperscalers is, okay, I just don't need to worry about infra. Another reason is that the cloud is now 20, 30 years old, and we're so used to it that there are a lot of what used to be people who were system admins and would install servers and so forth. A lot of those people these days are trained on dashboards, right? So the idea of doing bare metal installs and so forth sounds scary because, and I can understand it because frankly, that's not what they're used to or they've been trained to do, right? But installing a bare metal server still remains not that difficult, especially if we're talking about a cloud engineer, a programmer, and so forth. So this repatriation movement is trying to say, hey, don't buy this sort of lie that hyperscalers are selling you that having your own bare metal server is difficult or some black art or super, super complex, especially since today you can sort of go on a website and rent a bare metal server and within a minute or two you have it and you can sort of log in, install things, and you're done, right? So I think there is going to be an increasing sort of shift to go there. Some people are stuck within hyperscaler infra, but even Amazon rents bare metal. So if you see dot metal instances, those are bare metal servers as well.
So, but that does not completely answer my question. Do you think that we're going to see more and more on-prem? Because you said it's not that hard. So will we see that? And especially in relation with AI, because now one of the most interesting side effects of the AI wave is a bigger surge in open source solution. And I wanted to also ask you about open source because Unikraft is a commercial open source company. So now that you have all those open source bricks to build your own AI infrastructure, do you think that enterprises, especially in sensitive industries, regulated industries like healthcare or financial services, will build the whole stack themselves and just say thank you to the hyperscalers, but we're not interested?
Yeah, so to answer your question, yes, I do think there'll be more and more on-prem or bare metal deployments increasingly, as especially in the AI world where even a really early company may hit scale very fast, and this is like almost an immediate concern. No, it's standard company would say, okay, I start today, and maybe in 2 years I have a scale problem. An AI company, I start today. And at day one, I'm already worrying about scale. And maybe in 3 months, I've hit it, right? So the AI space, scale matters a lot more. And, going to metal makes a lot more sense very quickly. Enterprise, of course. So yeah, I think that is where the trend is going to be going increasingly. This doesn't mean that people will totally leave hyperscalers, and probably for the same company, they'll be using both Metal and some hyperscaler in a sort of hybrid mode. So it's also not going to be like the repatriation proponents saying that the cloud will be crickets in a few years. It's not going to be that either.
So my last question for you is related to open source. So you made the choice to start with an open source project and you built a company around it. And I know that a lot of commercial open source founders are listening.
Yeah.
There are more and more of them, especially in Europe, where open source is increasingly becoming synonymous with sovereignty. So, why open source, and why do you think that open source, commercial open source, is a model that's going to win bigger in the coming years?
Yeah, so for us, it was a very natural place to start because when we started all of this, we were researchers. So, you don't even think about it. You write code, you open source it, right? Um, but we also wanted people to build on it, even commercially. So from the beginning, Unikraft had and still has a BSD license, right? Unikraft, I should say, that's the unikernel project that's always sort of open. When we decided to go commercially, we said, okay, this is it, as an anecdote. One thing that naively we try to do is let's take unikernels and put it into an AMI and deploy it in AWS. And if you do that and you hit on the go button on the dashboard, it'll take like 30 seconds to start, right? And so, it's like, where did my 10 milliseconds go? So this is the discovery process many years ago of a cloud platform is just not only the really fast image. And that got us into having to build the other components. And because we're open core, and obviously we need to have some level of closed components, otherwise the hypervisors would just eat us alive. We kept the other things closed. The unikernel part is still open, fully open, and all of the tooling around the platform, the APIs, the CLI, the SDK, all of that is still open. So I think it's definitely a viable model, especially if you're in the space that we're in, DevOps, infra, whatever. I think if you're a company, if you're an open core company, you have to keep some components closed. Otherwise, you're too vulnerable to hyperscalers coming in and sort of grabbing all your components and throwing them together if they think you're onto something, right? So you have to keep that in mind, right? There are some really big players in the space that you have to be aware of. So I think it's a viable model. I think you should go for it, and you should keep an eye out for big players in the market.
All right, Felipe, that was my last question. Thank you very much for answering all those questions today. I feel much smarter now than I was 40 minutes ago. Before I stop the recording, is there anything else that you wanted to share to the audience about you or Unikraft that you haven't shared?
Um, Yeah, it's a good question. I mean, I don't want to speak about anything commercial. So, if clearly my sort of the underlying theme is that we maybe have a solution to these problems. But mostly, I would be interested in getting any sort of feedback. Was this interesting? Did it answer questions? What answers did I miss? Are there follow-ups? That would be really of interest to me.
Thank you very much, Felipe. It was a pleasure. And where can people hit you up? Can they contact you on LinkedIn?
Yes, definitely. I'm on LinkedIn. I have a strange enough name that you shouldn't get multiple hits. It'll be me. I'm also on X, so any means of communication works.
All right. Thank you very much, Felipe. Have a great end of day, and I'm gonna stop the recording now.
Thanks, Daniel.